So the shifting agriculture often employs polyculture or planting of a mixture of plants. That's the benefit of this method. And the downside is labor intensive, but it is still practiced in much of the world. And the primary reason for the use of labor-intensive agriculture is economic, and it lasted several thousand years. It is still prevalent in some of the areas of the world today. This is a slide for current agriculture in developed countries. So in industrial countries, the Industrial Revolution discovered fossil fuel that help people to invent machinery and manipulate land like this. So the benefit is, of course, greatly increase of the efficiency and enhance the yield a lot. And but it requires burning of the fossil fuel, so that contribute to global warming. And this method requires a lot of energy use and flat land, and not all over the world have this such landscape. As technology evolved, the labor was greatly reduced every 50 years, and you can see almost like 10% of the labor was used after 60 years to produce the same amount of corn. And this method also introduced the use of fertilizer and pesticides. So it takes 5 metric tons of fossil fuel to produce 1 metric ton of fertilizer. And the issues with the monoculture here, I know I jump pretty fast here because I want to give you an overview of the picture before we go into our focuses of the chapter. It increased soil erosion and loss of biodiversity. Usually just one crop was planted in such big land, a few rounds a year. And that increased the pesticide use, increased the fertilizer use, and again, the fossil fuel energy use has replaced human muscle power. So that needs a lot of burning of the fossil fuel. So that is one of the reasons of the global warming today. And 25% of the world's agricultural crop is attributed to chemical fertilizer use. If you recall what we talked about before, and we know not most of the land need fertilizer, then why we're using tons of those chemicals? Because we are pushing the land's capacity to push the land's natural capacity to yield crops, right? Probably in nature, we do this once a year, and then now with this monoculture, we can do 3 times a year. And we replenish the land with those chemicals. So the chemicals we majorly refer to are the macronutrients and the macronutrients. Macro, M-A-C-R-O, the macronutrients, the 3 primary soil nutrients are nitrogen, phosphorus, and potassium. And plants also need those tiny amounts of macronutrients to grow, also like boron, zinc, and manganese. So the orange bar here, the yellow bar here is 1960. So it was almost 60 years ago. If we look at the last group of bars here, the world total, you can see in 1960, It's about like 25, 30 million nutrient tons. And around 1990, the year I graduated from high school, it increased to 150. And in 2020, the projected use is over 200. So let's think two sides, two parts of the world, the developed world and the developing world. In the developing world, that trend is still going up. And in developed countries, it's almost saturated. But overall, worldwide, it's still increasing a lot. Over 200 million nutrient tons. That's how many chemicals we put in the environment. Of course, they are useful, but they also bring a lot of environmental problems. So the chemical fertilizers, the one issue is they cannot replace soil organic matter. What nature gives us is the best. We cannot synthesize all the components nature give to us, to the environment. And those soil organic matters, that is important for soil structure. And total dependency on chemical fertilizers usually reduce the amount of organic matter and can change the properties of the soil. So we're gradually shifting the properties of the soil towards the properties we wanted instead of the nature give to us. A pesticide is any chemical used to kill or control populations of unwanted living organisms. Unwanted does not mean not necessarily existing in nature. So we humanly selecting what kind of living organisms in the environment by using those chemicals. And the pesticides have several categories: those to kill insects and fungi, rodents, herbs, and or weeds. Biocides kill a large variety of organisms. The point about this slide I want to think about is unwanted doesn't mean they do not have a significant role in the natural environment. I will use this as a good example to explain the effects of using resistant chemicals. And the DDT has wide applications all over the world. It was started being used around World War II. So between 1946 and 1950, the malaria case dropped from 400,000 to virtually none, because this is a chemical very efficiently killing mosquitoes. And if we look at this picture, this is in the old days how people spray those. They think it's pretty good. Of course, in early years, they did not realize, I mean, from the short-term studies, they did not realize DDT has a long-term effects in the environment and to human health. And this slide shows how many diseases a mosquito can carry. More than 30 diseases, and killed more than 800,000 people per year. So this is the primary reason why we use those chemicals in the early years. And the DDT has a lot of problems, and 20 years later, it was completely banned in USA. It is still used in South Africa, Africa, and Asia, but now people are very cautious of using those chemicals, and it is persistent. The half-life of DDT is about 10 to 15 years. And think this way, it's almost in the environment forever.